Hi everyone. In the last class, we were discussing about the unit number one, that is Introduction to Operating Systems Structures. So, in that, we discussed about what is an operating system, what operating system do, then computer system organization, computer system architecture. Then, in this class, we are going to discuss about operating system structures. Okay, so under operating system structures, we are going to study what are called as operating system services, user operating system interface, system calls, types of system calls, system programs, then operating system design, design and implementation, operating system structures, virtual machines, operating system debugging, operating system generation, then system boot. So these are the other topics which we are going to study under operating system structures. So let us start with the operating system services. Just a moment. Yes, here it is. It is 1.13 operating system services. Okay, so what is the objectives of this operating system structures? Okay, the objectives of this particular operating system structures are to describe the services of an operating system and provides to the operating system that provides to users the processes and the other systems to discuss the various ways of structuring an operating system, to explain how operating system are installed and customized and how they boot. So these are the objectives of this particular operating system structures. Okay, so now we'll see what are these operating system services. Okay, so the operating system, one set of operating system services provides the functions that are helpful to the user. Okay, then the other set of operating system functions exist for ensuring the efficient operation of the system itself via resource sharing. So these are the two services, main services which provides by the operating system. So under these category, under these two categories, there are some more services which are going to be provided by the operating system. So let us see one by one. The first one is we can say program execution. Okay, so the system must be able to load the program, and it is going to load the program into the memory and to run the program. That is the job of the particular OS. This is one of the job, one of the services which is provided by the operating system, and the execution either normal or abnormal. Okay, so it can be a normal one or abnormal one based on the program. Okay, so then after, if it is an abnormal one, okay, so then it has to indicate the error. Okay, so that is called as the program execution. Then the second one is going to be the IO operation. Okay, so what is this IO operations? The operating system has to allocate resource for the programs, the IO resources for programs, that is input output resource for the program. A running program may require IO services, which may involve a file or an IO device. So file, it may be a read from the file, or it is going to be it is going to write the contents into the file. Okay, so based on the requirement of the program, the IO services are going to be provided by OS. Then the other one is the file system interface. So what is this file system interface or file system manipulation? The file system is of particular interest. So obviously Programs need to read and write files and directories, create these particular operating system provides an help to it assist the programs to delete, to create, okay, the files as well as the directories, then search them in the list, and file information, permission management. So all these particular services are going to be provided during the course of what is called as file system manipulation. So this is the service which is going to be provided by OS. Then the next one we can say the communication. Okay, what is this communication? In certain situation, one process may require to communicate with the other process. Okay, so one needs to change the information with another, so or exchange the information with another at the time. So the particular OS comes into picture and it helps the particular process to exchange the communication between those two. Okay, so then the process may exchange information on the same computer or between the computer or a network that can happen. Okay, so within the program, within the processes, they can exchange the information, or else between the computer, one computer to another computer, there may be a possibility that a process can exchange the information. So that is what is called as communication. So between one computer to another computer means there must and should be a network. So without network, the particular exchange can not happen at the time. Okay, so network must be there. So if not internet, only the LAN is sufficient in order to exchange the information between one computer to another computer. Communications may be via shared memory or through message passing, packets moved by the OS. Okay, so in this case, the communication may be via shared memory. So the memory is going to be shared. If it is a common memory, that memory can be shared by many computers, many processes. So the process can utilize the service of that particular memory. Whatever the resources which are which are present in that particular memory can be availed by the each process. Okay, so that can be done, and these particular, or else the messages can be passed between the two, and also the packets are moved by the OS. The job of this particular OS, or the service of this particular OS, is to move the packets from one system to the other system. Then the next one is going to be what is called as the error detection. Okay, so the error detection. Errors may occur in CPU, IO devices, or in main memory hardware. Okay, so OS needs to constantly aware of possible errors. Whenever there is a possibility of errors, then OS must and should aware of what may be the outcome of this particular program, and what if the errors are going to be generated. If the errors are going to be generated, and it is going to be displayed to the programmer or the user. So OS needs to be constantly aware of the possible errors, what may be the possible errors, and that may occur in the CPU and memory hardware. Okay, so in IO devices, or else in case of the user programs also, there may be a problem, or there may be an error. So that can be detected. For each type of error, OS take the appropriate action to ensure correct and consistent computing. For each type of error, so it is going to generate a separate error code or separate error. Okay, so and it is going to be uh, it is going to ensure what type of error it is, and consistently it computes those errors. Okay, so then the next thing is in the error detection debugging facility. The debugging facility can greatly enhance the debugging facility can greatly enhance the users and programmers abilities to efficiently use the system. Okay, so it provides the debugging facility that can enhance the user as well as the programmer's ability to efficiently use the system. So this is regarding the error detection. Okay, then this all this belongs to one set of services that is provided by the OS. Let us see now what is the other set of services that can be provided by the OS. The other one is resource allocation. Okay, so there will be many resources in the particular computer that can be allocated among the processors. Okay, so equally they can allocate whenever there is a need, whenever there is a requirement, then the process can be allocated to each, the resources can be allocated to each process to execute its time of execution time. Okay, so to execute the program of its own execution time. So the resource allocation, when multiple jobs running concurrently, resources must be allocated to each of them. Okay, suppose say there are 2 to 3 programs which are executing concurrently. Okay, so simultaneously there are multiple number of what are called as programs which are executing. So at the time, each program may require some may require IO devices, some may require memory devices, some may require the other resources which can take care of the computing, the error detection, then all those whatever the possible services that can be provided. Okay, so all those particular resources can be allocated by the OS. Okay, so the many types of resources. What are some resources like some resources such as CPU cycles, main memory, then file storage. Okay, so may have a special application code. Others such as IO devices may have a general request and a release of code. So these are the requests which can be made by the process, or these are the resources that can be allocated to the process. Okay, so then the next one is the accounting. To keep the track of which user use how much and what kind of computer resources which are required. So all those is accounting. So it provides, the OS provides accounting. It takes care of what are how many number of processors are there, and what process is executing now, what process is in the queue. So all those accountability it keeps track of, it keeps track. Okay, then protection and security, of course, the at the final, this is the final where the attention has to be given how we can give protection and security, that the owners of information which are stored in a multi-user or network computer system may want to control the use of that information. So at the time, the security and the protection has to be provided. Okay, the concurrent process should not interfere with each other. Okay, so these are the protection and security that is going to be provided by the OS. Let us see what is that protection. The protection involves ensuring that all access to system resources is controlled. Then the security of the system from outsiders queries, users authentication extends to depending external IO devices from invalid access attempts. So the security has to be provided that the external user should not access the information of a particular process which is going on with the particular system, or a personal system. Okay, so that can be the security can be provided. If the system is to be protected and secure, precautions must be instituted throughout it. A chain is only as strong as its weakest link. Okay, the chain. Okay, when we have a network, there is a possibility that there may be a possibility of leakage of information. Okay, so we have to be very careful. That's why we need to provide security that can that can serve the purpose. Okay, so the next topic, I think you might have understood all these things. So now the services are like we have, so one more service, of course I have forgotten, that is user interface. I think it is not there in this notes. Okay, so one more is the user interface. So what is that user interface? Almost all operating system have a user interface. The user interface varies like between there is a command line, then graphical user interface GUI. Okay, so these are the interfaces. OS has to provide these interfaces. Without these interfaces, the programmer or the user cannot interact with the system. So it has to OS has to support or provide the service for the user interface. Okay, so these are the services which are going to be provided by the operating system. The first one is user interface or the program execution, you can consider, because at the last I told the user interface. Okay, so you can have first as user interface, then the second one is going to be the program execution, then the next one is going to be IO operations, then the other one is going to be the file system manipulation, then the other one is communication, then error detection. So these are the operations, some of the operations which are services which are provided by the operating system. Okay, and also in addition to this, I have forgotten to tell, just we discussed like a resource allocation, accounting, protection and security. Okay, so these are the services which are provided by the operating system. Let us start with the operating system interface. The next one is going to be the operating system interface. Command line interpreter system, CLI. Okay, so command line interface, you can say CLI is nothing but command line interface. So what is this command line interface? The command line interface or command line interpreter, it is also called as the command line interpreter, allows direct command entry. So you might have seen in the Unix or this particular uh, this Linux, all those, okay, Fedora, so where you need to give the commands, is it not? So there it directly interacts with the system using the system commands. We need to give the system commands. Sometimes implemented in kernel also, sometimes by system programs also. There will be some separate system programs, so that can be loaded into the system, that can be used for the purpose of executing the commands. Sometimes multiple flavors implemented shells. So shell scripts, you can use the shell scripts in order to execute the command in the command line interpreter. Okay, so then primarily it fetches a command from the user and executes it. So just very simple. So even we have a disk operating system in case of the earlier days, where we have DOS, it is called as MS-DOS, Microsoft Disk Operating System. Okay, so in the disk operating system, so you will get a command line. So in the prompt, you will get a prompt, C prompt or D prompt or E prompt, whatever it may be. So there we are going to execute the commands, is it not? Okay, so likewise, so here also, while what are the commands you can use, like calendar, then copy, then you can type the contents of the file, then you can list the directory, so using the dir command, so all those things. So using those things, you can able to interact with the command line interfacer. Okay, so if the latter if sometimes the command built in, sometimes just names of programs. Okay, so anything may be possible. Okay, so as primarily it executes the command, that's it, it is the command line interface. Then the next one is going to be the what is called as the user operating system interface, GUI. Okay, so what is this GUI? User friendly desktop metaphor interface. So this GUI is a user friendly. You might have seen this GUI. Usually mouse, keyboard and monitor. Usually you have this particular mouse, keyboard and monitor. You have icons represent files, programs, actions. Just you see the Windows desktop. So it is a graphical user interface. Okay, so there you can see the icons. If you click on icons, okay, so it explores whatever the contents. It is like a folder, so that explores, then it will show the contents of that particular folder. So all those things, it requires mouse, keyboard, monitor, all those things. Okay, so then it is user friendly actually, compared to the command line. It is user friendly. Okay, so it's very easy to interact with GUI compared to the CLI, that is command line interpreter. Okay, so user friendly. Then icons represents files, so definitely each icon is going to be a file. Then or else it is a program or some action to be taken, so etc. So each icon represents either a file or a program or action, whatever we want to execute. Okay, so various mouse buttons over objects in the interface cause various actions, provides information. Then the options, you can get on options there. Then execution function, then open directory. Okay, so or known as open directory also, it can be a known folder also. Okay, so likewise, then many systems now include both CLI and GUI interface. Yes, of course, we have all the systems. Most of the systems we have the command line interpreter as well as the graphical user interfaces, where it is user friendly. Sometimes where we may require the disk operating system also. So that is a command line interpreter also, through which we can give the commands. Okay, so sometimes you may use commands, or sometimes you may use program or some actions also. So in that case, you need to have the CLI as well as the GUI. Okay, so Microsoft Windows is GUI with the CLI. As I need not to tell all those things, because whenever you click, if you exit from a particular thing, then you can go back to what is called as the CLI, that is the command line, or it is a command line interpreter. So to that interpreter you can go, you can able to execute the shell scripts or any scripted languages there. Okay, so Apple, Mac OS, Aqua GUI interfaces with Unix kernel underneath the shells available. Okay, so these are the some of the operating systems that can have the GUI. Then Sun Solaris, that is Solaris is CLI with the optional GUI interface, Java Desktop, KDE. So all these comes under GUI. Okay, so then we'll see what are called as the system calls. Okay, the next is going to be the system calls. Okay, system calls, system provides interface between the process and the OS. So there must and should be a system call whenever. So each process can have a call. So each process will be running concurrently within the process. Okay, so within the execution, at the time the particular process has to be invoked by the call. So the particular OS provides these particular calls. Okay, so program interface to the service provided by the OS, typically written in high level language. These particular system calls will be written in high level language, either C or C++, mostly accessed by programs via high level application program interface APIs. These called as APIs. The system calls are called as APIs, rather than direct system call use. So we can make use of the application program interface, that is API, in order to interact with these particular processes. Okay, so three most common APIs are Win32 API for Windows, POSIX API for POSIX based systems including virtual, all versions of Unix, Linux and Mac OS, and Java API for Java Virtual Machine, JVM. Okay, so these are the system calls, and several languages have been defined to replace assembly language programs. A system call instruction generates an interrupt and allows OS to gain control of the processors. Okay, so these are called as the system calls. Why APIs rather than the system calls? Okay, so what made you to go for the APIs rather than the system calls? For example, take for example the system calls, like a system call sequence to copy contents of one file to another file. Okay, there will be a source file, there will be a destination file. Okay, so for example the first one is a system call sequence. How the system call invokes, acquire the input file name. First you need to know what is the file we are going to load, is it not? Okay, so what is the source file, what is the destination file? Okay, so likewise with a attempt to with a prompt to screen, so you need to write a prompt to the screen, accept input, next you need to accept the input, acquire the output file name, so you need to acquire the output file, then write the prompt to screen, so you need to leave a message on your screen, so you need to write accept input, you need to accept the input next, then open the input file, then if the file does not exist, okay, so abort the process if the file does not exist. Otherwise you create output file. If the file exists, abort. Okay, so if the file exists already, abort the loop. Okay, so then the next steps what is going to be like, read from the input file, then write to the output file. So if everything is correct, if you open a source file, the output file is created, everything is right, then read from the input file and write to the output file until read fails. Okay, so read fails means end of file. So it reaches the, if it is reaches the end of file, then stop it, then close the output file. Okay, then write completion message to the screen. So you need to it has to leave the command to the output screen after completion of the writing. Okay, so temporarily or normally you terminate the terminate normally, so we need to terminate the process. So this is the system calls, or this is the sequence of system calls which are going to be generated during this particular process, from copying the contents of one file to another file. Okay, so then how you can able to implement the system calls? Okay, how you can able to implement the system calls? System call implementation, typically a number associated with each system call. There must and should be a unique number for each system call. System call interface maintains the table, so there will be a table which is indexed according to these numbers. The system call interface invokes intended system call in OS kernel and returns status of the system call and any return value. The caller need to know nothing about how the system call is implemented. We need not to caller. Okay, the caller, whatever the process may be there, it need not to know. Okay, nothing about the how the system call is implemented, just needs to obey API and understood what OS will do as a result call. Okay, most details of OS interface hidden from programmer by API. So everything will be hidden by the API. So managed by runtime support library. Set of functions built in libraries include with the compiler. So all these particular system calls are already readily available within the system. Okay, so we need not to worry about that. Then what are the system calls parameters passing? Okay, so often more information is required than simply identify of desired system call. Exact type and amount of information vary according to the OS and call. Okay, so the three general method used to pass the parameters to the OS are: simplest is that they pass the parameter in registers. You can pass the parameters using the register. So here you can see the X register. Okay, so just you pass the parameter to the X. This is the simplest way. in some cases maybe more parameters than registers. You can use more parameters. There may be a possibility that there may be a more parameters than the registers. Parameters stored in a block, so definitely the parameters are going to be stored in a block or a table in memory, and addresses of block pass to a parameter in the register. Okay, so here you see the in the load address x, so it is going to be the x is the parameter here. It is passed on to the register. Okay, its address is loaded to the register in turn. Okay, so this is going to check in the operating system whether this particular parameter is present or not. Okay, so code for system call, so we need to know the code for system call next. And this approach taken by the Linux and Solaris. Okay, so let us see here how this particular thing is happening here. This is the user program. We have the x parameters from call, and next we have the load address x, then the system call 13. Okay, so these are the various parameter passing to the OS. So we can have a register, x register, you can send from the register, or you can have a system call directly. You can make use of the system call. You can call the parameter, you can call the particular process, okay, using the system call. Code for system call 13. So here the code is written. Okay, the code is, I'll show you. Okay, in the diagram, just you go through the diagram. In the diagram, it is given code for system 13. Actually, in the operating system, there will be a definitely there will be a code for the system call 13. So that is going to be invoked. Okay, so when the system call is activated, then it will check for the code in the operating system. Okay, so three general methods are used to pass the parameters to the OS. The simplest approach is to pass the parameter in register. In some there can be more parameters than the register. In these, the parameters are generally in a block or table. So there may be a block or there may be a table. In that also all the system calls are stored, like system call 1, system call 2, system call 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So likewise, so all these system calls will be having the unique number. So and also all the definitions or the code will be available within the OS. Okay, so then the parameters can be placed to into the stack, push into the stack, push onto the stack by the program and popped off the stack by the OS. So push and pop operations can be performed by OS whenever it is required. The parameters can be pushed and it can be popped based on the requirement. Some OS prefer the block or stack method because those approaches do not limit the number or length of parameters being passed. So any number of parameters, any number of any length may be passed. There is no limit at all. So because of that, these stacks are going to be used. System calls may be grouped roughly into 5 categories. So what are these categories here? So I think there may be another category also. So the other category may be the first category is process control. Then the second one is file management. Third one is device management. Then the fourth one is information maintenance. Then the fifth one is communication. Okay, so one more is there. It is not 5 categories. One more is the protection. So we need to consider the protection also. So protection system calls also there. Okay, so system calls may be grouped roughly into 5 categories. They are given here in this notes, but you consider it as 6 categories. Okay, so the first one is process control, second one is file management, third one is device management, then information maintenance, communication, then protection. Okay, so these are the different kinds of system calls which are available in OS. Okay, so now let us see, so what are called as the system programs. Mainly system calls are used to transfer information between user program and OS. Okay, so these are the system programs. The system programs are the programs which are machine dependent. Okay, the system programs are the machine dependent. Okay, for example, OS itself. OS is the what is called as the system program. Okay, so which is machine dependent. So what is machine dependent, what is machine independent? Okay, so without this OS machine can run? No. Okay, so likewise, what about this particular C or C++? Definitely C and C++ known by the it can easily understandable by the user. So that is why it is called as machine independent. Okay, machine dependent, only the machine can understand. Okay, so machine can understand like low level language. Okay, so that is the zeros and ones, only the machine can understand. This is the, that is how you can categorize these system programs. System programs have the system calls to return the current time, date, number of current users, version number of OS, amount of free memory or disk space, and so on. So, using this particular system programs, we have a system calls that can return the time and date, number of current users, version number of operating system, amount of free memory or disk space, and so on. In addition to the OS keeps information about all its processes, and there are system calls to access. Okay, so definitely there must and should be a system calls to access those programs. Okay, so system program provides convenient environment. System programs, just a minute. Where we are, yes, we are here only. System programs, yes. Okay, so these system programs provides a convenient environment for programs development and execution. They can be divided into, so you can have the division of system programs. So here it is not there actually. Okay, so you can have like the file manipulation, status information, file modification, programming language support, program loading and execution, communication, application programs. Sorry. So these are the categories of system programs. System programs provides the convenient environment for program development and execution. The most users view the operating system. The operation system is defined as system programs, not the actual system calls. Okay, so it is going to be the system programs, not the system calls. So we have some software within the program, so which is nothing but the system programs. Okay, system software, system programs. So they are not the system calls actually. Okay, so system programs provides convenient environment to develop and execution. Some of them are simply user interface to system calls. Others are considerably more complex. Okay, so here also others are more complex. Then others provides details performance logging and debugging information. Then typically these programs format and print the output to the terminal or other output devices. Some systems implement a registry used to store and retrieve the configuration information. Okay, so then system programs uses the file modification text editors to create and modify files, then special commands to search contents of files or perform transformation of the text, Then we can have a programming language support. Using the system programs, we can have a programming language support. Then we have compilers, we have assemblers, we have debuggers, and we have interpreters. Sometimes it provided by the programs loading and execution. Then we have absolute loaders. We have relocatable loaders, linkage editors, and overlay loaders, debugging systems for higher level and machine language. Communication provides the communication provides the provides the mechanism for creating virtual connections among processes, users and computer systems. Okay, so these allows user to send messages to the to one to another. Okay, for example, screens, web pages, and sending electronic mail messages, login remedy, logging in remotely, then transfer of files from one machine to another machine, then design and implementation of OS, then internal structures of different operating system, then start of defining goals and specifications affected. These are affected by the choice of the hardware type of system. Okay, so then the goals and system goals. The user goals, there are two things. Yes, user goals and the system goals. User goals, operating system should be convenient to use, easy to learn, reliable, safe and fast. So that is the user goal. Then what is the system goal? Operating system should be easy to design, easy to implement, and easy to maintain, as well as flexible, reliable, error free and efficient, of course. Okay, so then important principle to separate the policy and mechanism. Okay, what policy says what will be done, so that is the policy. Mechanism says how to do it. Okay, so these are the two things when it comes to the principle and separate this thing. Okay, so mechanism determine how to do something, then policy decides what will be done. Okay, so the separation of policy from mechanism is a very important principle. It allows maximum flexibility if policy decisions are to be changed later. Okay, so this is what about the system programs. Then I will stop it here. We'll continue in the next class. Thank you.